Hello everyone, my name is Eddie Britt. I'm your instructor, of course, and we are going to work on your final exam review today. I'm going to work as much of this in detail as possible, and if you have any questions about anything, just feel free to send me an email or give me a call if you need to, if it's during my office hours. So let's start with problem number 1. All right, identify the population being studied. So the overall exam scores of 14 of the 37 students in your biology class. So that would just be like a small part of the population. So all of the students in your biology class would be the population. All right, sales in dollars made by a salesperson, or example, what type of data? So dollars, money, numbers, that's quantitative. All right, some of these problems, if they require you to do calculations, I've already done those in advance, so I may not push them in the calculator, but or punch them in the calculator, but you'll see what I get out. I'll write it down. All right, so a mid-sized mobile carrier keeps records of complaints received by its customers. Complaints for the last month are listed in the following table. What percentage of the complaints are due to the category poor tech support? All right, so poor tech support is 118 of those. So we're going to say 118. No, that's poor coverage. I'm sorry. Poor tech support's 106. So we're going to say poor tech support 106. Divided by the total number of complaints. So you have to add all these up, and you're just going to say, and this is problem number 3, you're going to say 106 divided by, and then again you have to add up all the complaints, and I believe you get 790, and then when you punch that in the calculator you're going to get 0.13417. It just keeps going on and on. It says to round to 2 decimal places. And I think it wants you to enter in the answer as a percentage. Okay, so if we enter it in as a percentage, this is the decimal, the percentage will be 13.417, so on and so forth, percent. But then it says 2 decimal places, so you want to round this number right here, so that'll be 13.42%. Okay, that's what they're looking for. That's the percentage of complaints that were poor tech support. Okay, I'm just going to go on to the next problem, even though I know that's the answer. All right, now here it wants you to pick out the frequency distribution. So what I did on my paper, I printed out this test. You could just, if you just clip something out, you could do this. If you have something you could write on, you clip out that. What I did is I went by and I made a mark by each weed eater. So I just went down and did this. All right, and then there's one there. So, and then I made like a different mark beside a push mower. So that's how many weed eaters. You can count those up. It looks like there's about 5. There's 5 of those. So then by push mowers, I come and I wrote the number 2. But I'm writing that by every push mower. That's just kind of, it's a different symbol that I'm putting beside it. So that way I can keep those separate. And then I went through and I did that for each item. And I put 3s by leaf blowers. I put 4s by pressure washers, 5 by rod and lawn mower. And then I counted up each one. All right, and so if you look at the choices, since this is multiple choice, there's only one that's going to be the correct answer once you've counted each type up, and it's B on that one, or the second one. You can see there's 8 leaf blowers, there's 6 pressure washers, so on and so forth. All right, so we got to use this chart to answer these questions. Find the lowest per capita personal income for the 6 states shown. Lowest. So lowest, that's going to be the small, whichever one is the smallest number, right? So that's going to be this one right here, 25,783. So, and I believe that's what it actually wants you to enter in, is that dollar amount, 28,783. So you enter that in there. And then step 2 is to find the highest per capita. So that's going to be the one that's the largest. So make sure you don't choose Washington. It's going to be California, 33,749. And again, it wants you to put in that dollar amount. So you put in 33,749. All right, find the mean of the set of data. All right, so to find the mean of a set of data, what do? We add up the data items. You add all those up, and then you divide by the total number of data items. So if you add all of those numbers up, and then you divide by 6, you will get -7. So your answer, your average, your mean of the set of data is going to be -7. All right, for median, you do actually have to do a little work. You have to rearrange these numbers least to greatest. All right, so this is problem number 6, step 2. So if you take those numbers and you arrange them least to greatest, it's going to be -14, -13, -7, I'm sorry, -8, -7, -5, and then 5. All right, now the median is the middle term. But we have an even number of items. So when you have an even number of data items, you take the 2 middle terms, add them up, and divide by 2. So if you add those 2 together and you divide by 2, you get -7.5. That's your answer for step 2. Step 3 says determine if the data is unimodal, bimodal, multimodal, or has no mode. For you to have a mode, a number has to be repeated. There's not a number that's repeated up here. So there's no mode. All right. And that's simply, that was step 3. That's what you would put in there, no mode. All right. This is a empirical rule problem. So I'm going to draw a picture to try to explain this one. Suppose that shoe sizes of American women have bell-shaped distribution with a mean of 8.18 and a standard deviation of 1.5. Using the empirical rule, what percentage of American women have shoe sizes that are no more than 6.68? No more than means less than or equal to. No more than would be less than or equal to. So if I draw a picture of a bell-shaped curve. Let's pretend that's bell-shaped. Right here in the middle, that's where our mean is, 8.18. That's not the same as a z-score. That's just the mean of the set of data. All right, so if we know that the standard deviation, one standard deviation, is equal to 1.5, and then it told us there's some value no more than, and we said it's going to be less than or equal to 6.68. All right, so how many standard deviations away is 6.68 from the mean? So if I was to say 8.18 minus 1.5, I would get 6.68. So that's one standard deviation below the mean. Okay. Remember, the way the empirical rule works is if you go one standard deviation below and one standard deviation above, then that's going to include about 68% of all your data items. Well, if all your data items are going to be 68%, are going to be within one standard deviation, that leaves, what, 100% minus 68%, that leaves 32% to be out here and out here. And it's symmetrical, so you divide it by 2. So we're going to have 16% here and 16% here. You know, 16 plus 68 plus 16, that's going to add up to be 100%. Now, we wanted to know what is the, let's see, it says what percentage of American women have shoe sizes that are no more than, so that would be less than one standard deviation, which was at 6.68. So it's whatever this percentage is, which is 16%. That's your answer for number 7. All right, this is a simple just proportion problem. We want to know the proportion of voters who plan to vote for the Republican candidate. It says there's 320 total, and there's 170 that said they were going to plan to vote Republican. So you'd say 170 divided by 320. That's your answer. All right, so 170 divided by 320, or 17 divided by 32. You can put in that fraction, or if you divide and round to 3 decimal places, I believe you get 0.531. All right, determine if the correlation between the two given variables is likely to be positive or negative, or if they are not likely to display a linear relationship. Remember, it's going to be positive if as one thing increases, the other thing increases. It's going to be negative if as one thing increases, the other one decreases. And there's going to be no correlation if they just don't have anything to do with each other. All right, so the number of cigarettes a person smokes per day and their life expectancy. I would think that as you increase the number of cigarettes that you smoke per day, your life expectancy is probably going to decrease. That's just kind of common sense. So as one increases, the other decreases. So that's got to be a negative correlation. Now, determine whether the following events are mutually exclusive. That means, can they overlap? Like, let's see what we were looking for. Choosing a diamond or a black card out of a standard deck of cards. So can we choose a diamond and a black card at the same time? No, we can't, because diamonds are red, right? So the diamond, that's going to be a red card, and then or a black card. No, you can't get both at the same time, so they are mutually exclusive. All right, this is a uniform distribution. No, this is just a regular probability problem. It says a classmate walks to a class and states he has an extra ticket for a festival on Friday night. Then he puts everybody's name in the hat. There are 18 people. What are the chances that one would be chosen? Well, if he's only going to choose one and there's 18 people, then that's going to be 1 out of 18. So 1 over 18. That's number 10. You can put that in, or if you put that in as a decimal, I believe you get 0.0556. All right, determine whether the distribution is a discrete probability distribution, and then select the reason for making this decision. All right, so your random variables can be positive or negative. Your probabilities, though, they have to be between 0 and 1, and they can include 0 or can include 1. And so all those look good. Also, when you add all the probabilities together, they have to be equal to 1. So 5/8 and 1/8, that's 6/8. Oh, and 1/4. So how many eighths is 1/4? That's 2/8. So 6/8 and 2/8 is 8/8. So when you add those together, you do get 1. So that meets all of, there it is. Probabilities lie inclusively between 0 and 1, and the sum of the probabilities is equal to 1. So it has to meet both of those. All right, so this is probability of, we want to know what is the probability of getting a head on a coin and a 3 on a die. So if you were to roll a die and you were to flip a coin. All right, so the probability of, this is step 1 on number 13, of rolling a head is just 1/2. Right, heads and tails, same probability. But and rolling a 3. If it's a 6-sided die, then that's 1 out of 6 chance that we're going to roll a 3. So the probability of both of these things happening, that's going to be 1/12. That's step 1. let's see, step 2. What is the probability of getting a tail on a coin and at least a 2? So what does at least a 2 mean? That means a 2, a 3, a 4, a 5, or a 6. So that's 5 out of 6 chance for that. So the way that this one changes, to get a tail, it's 1/2. But then to get a 2, a 3, a 4, a 5, or a 6, that's going to be 5/6 chance. So now multiply those two together and you get 5/12. So that's the probability of rolling a tail or a 2 or greater on your die. All right. All right, a certain insecticide kills 70% of all insects in laboratory experiments. A sample of 10 insects is exposed to the insecticide in a particular experiment. What is the probability that exactly one will survive? All right, the first thing that stands out to me is this is the percentage that it kills, but we're trying to figure out exactly one survive. So I probably don't want to use the percentage that kills if I'm trying to talk about how many survive. So what is the chance that the insect will survive? Is 30%, right? If it kills 70%, then 30% are still surviving. They're still out there flying around. So my P is going to be 0.3, not 0.7, because my success is that one survives. All right, that may seem a little confusing, but so P is 0.7. Also for my formula, I need 1 minus P. I said P was 0.7, P is 0.3. So 1 minus P is 1 minus 0.3 or 0.7. Now my formula, this is a probability distribution. So remember the formula? It was NCX times P to the X times 1 minus P to the N minus X. All right, so we had a sample of 10. So that means that my N is 10. And I want exactly one success. I want exactly one insect to survive. All right, so now I can just plug these in. So I need to find 10 C1, that's that combination, times 0.3 to the first power times 0.7 to the 10 minus 1 is 9th power. So remember, the way you work that out, that's 10 factorial over 10 minus 1 factorial times 1 factorial. Then times 0.3 to the first times 0.7 to the 9th. If you do all this in your calculator and you work it out, you're going to get about 0.12100608. And the problem asks, it says to round to 4 decimal places. So that means my answer is going to be about 0.1211. That's my answer.